Greetings, everybody. Welcome to IBC. My name is Floyd Christofferson from Hammerspace, and I'm here to talk about how Hammerspace can help with Storj create a global file system in the cloud to tie together your on-prem resources with the cloud. I'll cover a little bit what the challenges are of siloed environments in a hybrid world and how Hammerspace solves this problem, and how Hammerspace and Storj are better together and how the solutions complement each other and the ways that this can help customers. Let's start with a little bit with the problem first. And that is, everybody knows that when you have a storage system, the file system is generally embedded in that storage system. You've got one access to your data, and if you've got only one type of storage, your problems are not very big. But what happens when that storage fills up and you need additional storage? Now you have a new file system to deal with. Oh, by the way, what happens when you get more storage, or you want to move to cloud, or you have another site? What you now have is fragmented data, multiple interruptions for your users and your applications to even access that data. And so how do people solve this? In the traditional way, they have to layer on top of this point solutions. Again, additional cost to your infrastructure, friction to your workflows as you're moving data, making copies of these data that proliferate across multiple sites and environments. This adds a tremendous burden to any type of workflow, especially collaborative workflow. What Hammerspace does is, as you can see, we elevate the file system out of the actual infrastructure. So rather than your file system being trapped in the storage, we've elevated out of that. By having the file system above your storage, right next to your users and applications, what you now can do is manage all of your orchestration of data behind the scenes. Even with live files, while users are actively reading and writing them, we can be orchestrating data from high-performance storage, downstream, from remote storage, upstream. All of that becomes a transparent background operation. And what's important about this as well is that from a user standpoint, they see one global file system, and they don't have to install any client software. It's all native standards-based, SMB, NFS, Kubernetes, S3, whatever their protocol of choice to enter in the front side, Hammerspace can abstract that, but abstract it at extreme high performance. More importantly, this is also compatible with any storage of any type from any vendor, right, as a standards-based solution. But the cool thing is, your users may or may not even know that Hammerspace is there. They open up their computer, they see a desktop with no additional applications they need to do. They'll mount a file system and they'll see the data. But instead of seeing only the data from one particular storage type, they see all their data. If the data is in the cloud, if the data is on-prem, if the data is in a remote site, if it's scattered across multiple different storage types, all of that is abstracted. But from a control standpoint, your administrators, all of your compliance or any other type of control you want to have across the data, that your administrators have a global view. Again, they can fine-tune with objective-based policies how that data should be treated, and even extend it with custom metadata. So you can decide how the data should be protected, treated, managed across any resource, anywhere. The way it works is this. Hammerspace will be installed in an environment. It's a software solution that can run on any hardware, VM, cloud machine instance. Even we have Kubernetes, a CSI driver for Kubernetes. But what we'll do is we actually, what we call, assimilate the metadata with data in place. So this is a very fast operation, even in multi-petabyte environments, is we'll pull the metadata, but we leave the data in place. In this example, the customer may only want to pull a portion of the volumes out. And so that's fine. We'll harvest that metadata in. Immediately now, even before the job is complete, users can now mount the file system. It's a simple a share, just like any other share. And now they see the entire global file system. And what that means is that they can also automate the placement of that data. So maybe you've got old storage that you want to begin to migrate to new storage, or a portion of that data you may want to push up to Storj in the cloud. All of that can now be automated in the background without the users necessarily even knowing. Whether it's a single copy that you're making sure that it's placed where you want it, or if you want to create a data protection strategy that has multiple instances of the file. Again, this is not copy. This is a multiple instances of the same file because the file system is the same. The file system metadata is the same. Everybody everywhere sees this. And this is also important in hybrid environments where you may have multiple sites. This can extend, and we've got customers that have data centers all around the world. Everybody everywhere, the largest has got 16 data centers scattered around the world. It's an online gaming company that does massive amounts of data. But all of their users, whether they're in Singapore or in LA or in London, they're all looking at the same file system. That data movement, as I mentioned, it's all in the background. So they may be promoting or demoting data based on workflows or active projects, and they can do that transparently. And what if you want to do a massive rendering job and you need to push that into a GPU cluster, or you don't have GPUs in your organization because you can't buy them, they're not available. You want to, use a remote GPU service. All of that can be orchestrated transparently in the background. Again, your users and your applications are focused on their work. They shouldn't have to be focused on, manipulating copies of data everywhere. And that's really the advantage. Because once you've got the file system elevated above the infrastructure, now everything is possible. And this is key. So from a universal presentation layer, simple standards-based, no clients required, with the parallel file system, now, because you've got everything above the infrastructure, you can also implement global data services for data protection, copy management, versioning, the types of things that you would need in any kind of an enterprise environment, but you don't have to do that individually siloed by storage vendor. All of these can happen in the background. So in the real world scenario, you may have data centers in different parts of the world, and you may want to push some of that data into Storj. But again, what you don't want to do is now create a copy sprawl and copy management problem. With Hammerspace, all of this becomes the same global file system, a global namespace that spans everything. Every user in every location is seeing the same file system on their desktop, able to access that data wherever they are. And then the background data placement is completely seamless and invisible to the user. Whether you're pushing it to a GPU cluster or you're demoting it down into tape or sending a protection copy into Storj, all of that is transparent to the user. And the use cases are pretty much what you would expect. You might have multiple silos within a single data center, or you may have multiple data centers, you need to span them. Or you want to create a hybrid cloud, but you can't afford to buy more point solutions or have copy sprawl, or even the management of where is the data, and should all of the data be everywhere, or some of it? How do you manage that? Burst for compute, especially for rendering or GPU-based operations, computing, where you may not have the resources locally. You can spin up an instance and burst that automatically and then shut it down again, so you're saving costs. Being able to bridge cloud. You may have a requirement to use another cloud vendor that has compute resources, or some of your data may be there, but you don't want to necessarily keep it there. You'd like to bring it into a more affordable and convenient solution like Storj. You can do that because we can bridge not only multiple silos on-prem, but into multiple clouds. And then what if you've got distributed resources, like we talked about with the gaming company? You may have users everywhere. So what this means now is you've got unified access to your data that can bridge any of your legacy storage from any vendor with the Storj cloud. You can enable a global namespace that spans across silos, sites, and clouds with universal access for everybody. You can automate that data orchestration So the data will move automatically where it needs to move, but without interrupting your users, their workflows, or causing IT interruption. Even a simple migration from old storage to new, that now becomes a background operation. There's no downtime, no panicked IT activities over the weekend to try to do it without disruption. You can power this with a hybrid cloud NAS for high performance. So moving that, again, it looks just like a NAS, but where that data is placed is automated, and then bridging multiple sites. So this is Hammerspace, and this is how Hammerspace and Storj complement each other and enable you to build a comprehensive data management and data protection strategy across all of your workflows. Thank you very much for your attention.